Hello everyone. On this video we will be looking at how to solve definite integrals but using the midpoint rule. Okay, so just a quick reminder that if you look at the definite integrals for the left and right endpoints, where this is your definite integral, at least the definition. Okay, you see for the right endpoint, your c sub I, you can make that your x sub I. And for the left endpoint, your c sub I becomes x sub I minus 1. Where, of course, your x sub I minus 1 is left, and your x sub I is your right endpoint. Okay, so we know that when you find the upper sum, your upper sum estimate is always a little bit more than your actual area. Then when you find the lower sum, your lower sum estimate is always less than the actual area. So if the upper sum is more and the lower sum is less, then what we're going to do with the midpoint is we're going to meet right in the middle of those two. So if we're close for the upper sum and we're close for the lower sum, the midpoint sum gets right in the middle, so we're even closer to the actual area. All right, so for our midpoint rule, our area is going to equal the sum from I equals 1 to n of f of c sub I delta x, where our delta x hasn't changed. Our delta x is still equal to b minus a divided by n. But in this case, our c sub I is not x sub I or x sub I minus 1. Our c sub I is equal to x sub I plus x sub I minus 1 divided by 2, the midpoint between our left and right endpoint. All right. So if you are still writing, feel free to go ahead and press pause. But we're going to go ahead and move on to our first example. All right. So let's say, for example, if we want to use the midpoint rule to approximate, I'll just abbreviate that, approximate, the area of the region bounded by the graph of the function f of x is equal to x squared plus 3. And that's over the subinterval well, over the interval, that shouldn't be sub there, over the interval from 0 to 2 with 4 subintervals. All right. So just like before when we did the left and right endpoints, your first step is going to be to find your delta x, and whenever they tell you how many subintervals, you're going to find your n also. Okay, so just the fact that they told us 4 subintervals, we know that n is equal to 4. Okay, and we also know that our delta x is b minus a divided by n, where of course That's our A, and that's our B. So that becomes 2 minus 0 divided by 4. Which is 2 over 4, which becomes 1/2. So that is our delta x, our 1/2. Okay, now for our second step, we want to find our subintervals. So find our subintervals and our c sub i's. Okay, so we know that our interval is from 0 to 2. All right, so since we're going from 0 to 2, we're going to break that down to where each subinterval will have a distance of 1/2. Okay, so if we start at our 0, moving up 1/2, it goes from 0 to 1/2. And then if we start at 1/2, if we move up another half, that moves us to 1. Then if we start at 1 and we move up another half, that's 1 and 1/2. Then if we start at 1 and 1/2, and we move up another half, that takes us to 2. So we're from 0 to 2, but we're just moving in intervals of 1/2. Okay, now once we have our 4 subintervals, we find the midpoint of each subinterval using c sub I is equal to x sub I plus x sub I minus 1 divided by 2. Okay, so that's how we find our c sub I. All right, so we start with our first one, 0 to 1/2. So we go 0 to 1/2. We go ahead and add those two together because remember that's our x sub I and our x sub I minus 1. So we have 0 plus 1/2 divided by 2, which is 1/4. So that's our c sub 1. Okay, so we do the same thing with 1/2 to 1. So 1/2 to 1, we add those two together. So 1/2 plus 1 divided by 2. If we change that 1 to 2 over 2, we get 3 over 2 divided by 2, which is 3 over 4. Okay, now if we do the same thing for 1 to 1 and 1/2, go ahead and add those two together. So you have 1 plus 1 and 1/2 divided by 2. If you change this 1 and 1/2 to 3 over 2 and 2 over 2, you get 5 over 2 divided by 2, which is 5 over 4. Oh, this is our c sub 2, and this is our c sub 3. And if you do from 1 and 1/2 to 2, so 1 and 1/2 to 2, so we go ahead and add those two together. 1 and 1/2 plus 2 divided by 2. So if we make that 3 over 2 plus 4 over 2, that'll give us 7 over 2 divided by 2, which is 7 over 4. And that's our c sub 4. Okay, so the midpoint of each of these intervals will give us our c sub 1, c sub 2, c sub 3, and c sub 4. Okay, which brings us now to our third step, which is using the area with the midpoint formula. Well, using the midpoint formula to find the area. So our third step, we know that the area using the midpoint is approximately equal to the sum from I equals 1 to n equals 4 of f of c sub I delta x. All right, so just a quick note. If we know that f of x is equal to x squared plus 3, we also know that f of c sub I is equal to c sub I squared plus 3. Just changing the x to c sub I. All right, so what we're going to do is we're going to go ahead and replace each one of those. So I'm going to move this equal sign over a little bit. So f of c sub 1 is just going to be c sub 1 squared plus 3. So you have c sub 1 squared plus 3 times delta x, which is times 1/2, plus c sub 2 squared plus 3 times delta x, which is 1/2, plus c sub 3 squared plus 3 times delta x, which is 1/2, plus c sub 4 squared plus 3 times 1/2. All right. So now what we're going to do is we're going to factor out 1/2 from each of those terms, just so we don't have to keep writing it over and over and over. Okay, so that's going to equal 1/2. Then we're going to replace those c sub 1, c sub 2, c sub 3, and c sub 4s with the values up here. Okay, so c sub 1 squared is just 1/4 squared. So we have 1/4 squared plus 3, plus c sub 2 squared, which is 3/4 squared, plus 3, plus c sub 3 squared, which is 5/4 squared, plus 3, plus c sub 4 squared, which is 7/4 squared, plus 3. And all of that multiplied by the 1/2 that we factored out. Okay, so if we go ahead, and I should be able to finish it on this page. So that should be 1/2. 1/4 squared is 1/16, so you have 1/16 plus 3. Plus 9/16 plus 3. Plus, you have 5/4 squared, which is 25/16 plus 3. Plus 7/4 squared is 49/16 plus 3. Okay, so we simplified each one of those squared terms. So now we're just going to go ahead and simplify this. So we have 1/2. You have 49/16 plus 25/16 plus 9/16 plus 1/16 is 84/16 plus 3, 6, 9, 12. Okay, so if we want to combine these two, we just go ahead and get a common denominator. So that's going to equal 1/2 times, so you have 84/16 plus 192/16. We just multiply 12/1 by 16/16, get our common denominator. Okay, so that's going to give us 1/2 times 276/16, which is 138/16, which becomes 69/8 once we simplify everything. Okay, so that gives us our area with 4 subintervals between 0 and 2. All right. So if you are still writing, feel free to press pause. But we're going to go ahead and move on to our next example. All right, so let's say, for example, again, using the midpoint rule, to approximate, give that a little abbreviation, approximate the area of the region bounded by the graph of the function f of x equals tangent of x over the interval (0 to pi over 4 with 4 subintervals. And what we're going to do, we're going to round to the nearest thousandths. All right, so what we're going to do is we're going to start off with our first step, where we're going to find delta x and n. So we know we have 4 subintervals, so we know that n is equal to 4, and delta x is equal to b minus a over n. We know that this is our a, and this is our b. So that's pi over 4 minus 0 divided by 4, which is pi over 16. Okay, so that's our delta x. Okay, so for your second step, just like before, we're going to find our subintervals and our c sub i's. Okay, now when you're dealing with values like pi over 4 or something like that, it's a little bit easier. If you have another method, by all means use that, but this is one way you can split that up into 4 subintervals. Okay, so if you have 0 to pi over 4, just write out 0, 1, 2, 3, 4. Okay, so you want to split that up from 0 to pi over 4 to 4 intervals. Okay, so you already know from 0 to pi over 16 is going to be this interval here. So this is going to be your pi over 16, just from that value there. Now, what you want to do is you want to have all of them with the same denominator. So if you multiply this by 4 over 4, that'll give you 4 pi over 16. Okay, and then from there, it's just counting your numerator. So you go from 0, you have 1 pi over 16, 2 pi over 16, 3 pi over 16, and 4 pi over 16. Now, you could simplify this 2 pi over 16 to pi over 8, but I'd leave it like this because you now have everything with the same denominator. It makes it easier to add them together. Okay, so if you can simplify it if you like, but it'll just be, you'll have to take it back to 2 pi over 16 later, so you might as well go ahead and leave it right here. Okay, so if we go ahead and separate that 0 to power over 4, okay, so we know that from 0 to power over 4 is going to equal 0 to pi over 16. And then from pi over 16 to 2 pi over 16. Then 2 pi over 16 to 3 pi over 16. Then 3 pi over 16 to 4 pi over 16, which is our pi over 4. Okay, so those are our subintervals. So now we have to find our C sub I, our C sub 1, C sub 2, C sub 3, and C sub 4. Okay, so find our midpoint using C sub I is equal to x sub I minus 1 plus x sub I divided by 2. All right, so we start with our first interval, or first subinterval. So that's from 0 to pi over 16. So we go ahead and add those together and divide by 2. So we have 0 plus pi over 16 divided by 2, which is pi over 32. And that's our C sub 1. Okay, so if we go from pi over 16 to 2 pi over 16, go ahead and add those together and divide by 2. So pi over 16 plus 2 pi over 16 divided by 2. That's 3 pi over 16 divided by 2, which is 3 pi over 32. And that's our C sub 2. Then we go 2 pi over 16 and 3 pi over 16. Okay, so we go ahead and add those together. 2 pi over 16 plus 3 pi over 16 divided by 2. That gives us 5 pi over 16 divided by 2, which is 5 pi over 32. And that's our C sub 3. And if we do 3 pi over 16 to 4 pi over 16, add those together. Oh, clean up that 16 a little bit. Okay, so that's 3 pi over 16 plus 4 pi over 16 divided by 2. That's 7 pi over 16 divided by 2, which is 7 pi over 32. And that is our C sub 4. Okay, we have our C sub 1, C sub 2, C sub 3, and C sub 4. Okay, which brings us to our third step, which is the area using the midpoint, which is approximately equal to the sum from I equals 1 to n, which is equal to 4, f of C sub I delta x. Okay, so just like before, just note that we know that f of x is equal to tangent of x. So f of C sub I is equal to tangent of C sub I. All right, so we go ahead and we're going to solve for C sub 1, C sub 2, C sub 3, C sub 4, all multiplied by our delta x. Okay, so that's going to equal your f of C sub 1, which is tangent of C sub 1, times your delta x, which is pi over 16, plus or tangent of c sub 2 times pi over x, delta x, which is pi over 16, plus your tangent of c sub 3 times your delta x, which is pi over 16, plus your tangent of c sub 4 times your delta x, which is pi over 16. All right, so just like before, we're going to go ahead and factor out our pi over 16 so we don't have to keep writing it over and over. So that's going to be our tangent of c sub 1, so tangent of pi over 32, plus tangent of c sub 2, which is tangent of 3 pi over 32, plus tangent of c sub 3, which is tangent of 5 pi over 32, plus our tangent of c sub 4, which is tangent of 7 pi over 32. Okay, so if you plug these into your calculator and multiply it by pi over 16, you will get approximately 0.345 once you round it to the nearest thousands. Okay, so that would be your area using the midpoint rule over 4 subintervals. All right, so hopefully this made sense, and I will see you on the next video.